We now proceed ahead for applying the loads on the structure. So I have just jumped over to the loading tab. Now under the loading tab, for the walls of a tank structure, we need to assign the trapezoidal load or a varying load which will have maximum pressure at the bottom, and the pressure goes on decreasing as we come towards the top. So to start with, let us first assign the self weight. So I add a load case for self weight and assign the self weight itself. Okay, so I just add and assign it to all the elements of this view and click on assign. Now next load that I want to add is a water load, that is a water pressure on the walls from inside of the tank. So there is an loading type which is the fluid, and I just name it as a fluid load. And add. Now once I have added this load type, I can add a plate pressure load, that is plate loads. And under this plate loads, we have multiple options, that is pressure on the entire plate, a concentrated load on any plate. Then there is multiple option, and the last one is the hydrostatic pressure option. So using this type of loading, that is hydrostatic loads, we can apply a trapezoidal load simultaneously to all the plates of the wall that we have selected. And rather than individually applying to each and every plate or the finite element of the wall, if we use this option, then STAAD Pro will automatically calculate the pressure on each plate by whenever we mention the topmost pressure and the bottommost pressure. Now for applying the hydrostatic load, it is needless to say that the wall should be represented using an element mesh, which is already the case that we have under consideration. Now what we need to do is select the elements or the plates on which the pressure needs to be calculated. Okay, so there is an option of selecting the plates from here. I click on this and I will go ahead for selecting the plates. So I select the plate cursor and select the plates on which I want to assign the load. So just view the selected objects and select the plates which are parallel to my YZ plane. And once I have selected the plates, the list of the plates that are selected will appear here. Once we click on done, we will again come back to this form. Now over here, we are required to specify the pressure at the top edge. Now top edge can be actually the water line, that is by keeping some free port, whatever the top of the water line is there, we need to mention the pressure at that point and also the pressure at the bottom edge of the wall. Now these two locations are denoted by max global axis and min global axis. So we need to mention the W1 and W2. That is, say we are entering the pressure as say 15 and over here we enter as 0. Okay. So now I have to select the interpolating and direction. That is, for interpolating, the value generally is usually along the global y direction. That is, the pressure varies along this axis, that is the y-axis that we have selected. And we want to apply the load which is acting along the local z-axis of the plate. So we need to select, if we go ahead with local z-axis, And even if the wall is not aligned with the global plane, even then we can see that the pressure will be along its axis itself. So if I want to check the orientation of all these plates, I can just switch on my plate orientation from here, and I see that my z axis is pointing this side, that is, it is going on the right hand side, and I want to apply a pressure which is opposite to the z axis. So what I need to do here is mention the force or the load which is negative, so that it will go in the direction which is opposite to the direction of the z axis. So once I'm done with entering all these parameters, I can click on add. Okay. As soon as I click on add, the loads on each plate, which is a varying load, will be calculated over here. So when I go for viewing at the front, from the front view, and I click here, we see that the load from the bottom most edge of the wall, that is the maximum, up to the topmost will be presented in over here. Okay. Now we have to do this for all the walls of the bigger tank. Okay. So we will do this first. But before proceeding ahead, there is another way of just entering these loads or applying these loads, and easy to view it on this window. Now, this entire load that has been calculated on this wall has all these load presented here, and that too for one single wall. Now, when I add it for all the four walls of this bigger tank, it will be a much bigger list over here. So just to avoid and just to have a easy handling in the user interface over here, what I am doing as a workaround is I will add a reference load in the same way, like I will assign a hydrostatic load on the plates of all the four walls of this tank, and simply link it here with the under the fluid load case option. Actually, a reference load case is just like any other load case, but with a significant difference. The difference being that a reference load case is not explicitly solved during the analysis, but it actually exists only as a building block to be included in the primary load case. So what we are going to do in this example is we will define four different reference load cases for the four walls of the bigger tank, and similarly we will do for the smaller tank as well. So now these four and another four reference load cases will be defined, and then we will link it with a primary load case. The reason of doing this is if I go on defining all the hydrostatic load for a particular tank, then it will be a very big list of these loads, and it will be clumsy or not very much smooth in handling. So instead of doing that, I will do it with the help of a reference load case. So let's go ahead and do this. Under the definitions, we have the option of creating a reference load definition. When I select this, I just go on to add a reference load case, and I keep the type as none, as I will have a type for the primary load case. So now here I am just naming it as R1, and I will just mention in bracket for the big tank, so that it is easy to bifurcate which are the reference load cases for the bigger tank and which are for the smaller tank. So I just click on add. Once my reference load case is added, now I again go ahead and add a plate load. Now the further procedure will remain the same, like we have to add a hydrostatic load, go ahead and select the plate, So in the front view, I select these plates and mention the maximum and the minimum load intensity. Select the interpolating axis and click on add. Okay, so now once this is added, we need to do it for the other one. So I add another reference load case, name it as R2, and it is a big tank load. So I click on add and I will follow the same procedure for the other walls of the bigger tank. I will select the plates. Say I'm selecting these plates. Click on done. And for these plates, my z-axis and the direction of the load is the same. So instead of mentioning it as a negative intensity, I will mention it as a positive pressure, which is the maximum, and click on add. So now if I see R1, it is this load, and when I see R2, it is this load. Okay. Now I'm going to do the same procedure for the other two walls of this bigger tank. I will add R3 and R4. Okay. So what I have done is I have added the loads on other walls of the bigger tank and also added the load on the walls of the smaller tank. So if I just go ahead and look at the loads that I have added, then R3 is going to be load on this wall of the bigger tank and R4 is the load on this wall of the bigger tank. So when I view it from the left hand side view, see this is the load on the bigger tank. Similarly, I have added the loads on the smaller tank walls. 1, 2. Now for this wall, the load will be applicable only in this particular wall region. So what I did a specific and proper selection of these plates, which is common for both these tanks. Then this is the R7 load, and now we have the R8 load, which is on this one. Now what I am going to do is, I have a load case. I will add a reference load. So under the repeat load option, we have the option of adding the reference load. Now for the big tank, I will add all these four cases as a single load because the water load is going to act simultaneously on all the four walls of the bigger tank. So I add it under a single primary load. So I just add all these reference load cases and I am keeping the factor as 1 because going further when I am creating a load combination as a limit state load combination, it will already have a factor. So as of now, I keep the factor as 1 and add. So now I have one reference load. Now see, all these four load cases are acting simultaneously. Then I add another load with the same method, that is go to the repeat load. Under the reference load, I added for the smaller tank and keep the factor as 1. Okay, now what happens is I have the water load acting simultaneously on all the four walls of both the tanks respectively. Okay, so this is the way we can assign a fluid load to the walls of the tank. Next, what we add is the full pressure load on the bottom slab. So it is actually going to be a combination of soil load and fluid load. So just to give you a glimpse, I am selecting the plates parallel to XY and YZ, which are my plates of the wall. Now, when I see it from the top view, I have the portion which is enclosed within the four walls. So the slab area which is enclosed within the tank area will have a full pressure fluid load, which is the water load. And the plates which are outside the walls, I mean to say these plates will have a full pressure soil load on it. So what we will do, we will bifurcate and add both the loads, that is the soil load and the water load or the fluid load on that particular area of the tank slab. Now first what we do is, the simplest way of adding the first thing is to add a soil load on the outer plates of the mat foundation or the bottom slab. So what we can do is, we go on selecting these plates. So I have just kept the control pressed on my keyboard and I can select these plates. Now a few plates will be overlapped because of the type of the mesh that is created. Okay, so I am precisely selecting the plates based on its location. So this plate is more towards the soil part, so I have selected this plate. Okay, fine. Once we are done with the selection, I can select on view the selected objects. Now here our walls are also selected. So to just select the plates of the mat or the bottom slab, I go to the select option and click on select plates parallel to XZ plane. So all these plates will get automatically selected, and then in view option I will again see the selected object. Right. So now once all these plates are selected, I simply go to load cases, click on add. It's the soil load on mat. Okay, and assign the load type as soil. And again go to add, and under the plate loads select pressure on full plates. Now we will add this as a global Y pressure. So as global Y for STAAD is always up, we will add a pressure which is in a negative value. So let us add a pressure of -5 kilonewton per meter square and click on add. So once we have added this pressure, we need to select the plates on which we want to assign this pressure and use the option of assign to selected plates and click on assign. Yes. So now if we see, this soil pressure is applied on the plates which are on outside of the walls. Now what we do is, now we have to select the plates which are inside of the wall. So in the front view, what I first do is select the plates, the mat foundation plates, and for an easy selection, what we should do is, we should first select the plates which are highlighted in blue. So let us first just switch off the support symbol. So for the nodes, okay. So now it is very much resemble that these blue plates are the plates on which we have added the soil load. So what we do is first select these plates with the soil load. So carefully selecting the plates. Okay. So once I have selected the plates on which the soil load is applied, I can select the plates by using the inverse option. When I click on inverse, the internal plates will be automatically selected. As soon as this plates get selected, I just isolate this view. Okay, and then I go ahead to add a soil load on mat. Fluid load on mat, and change the type to fluids. Click on add and just add the full pressure or the pressure on full plates option. Again on the global y direction. Let us add a pressure of -7. Click on add. And now we can simply select all these plates and assign the load to the selected plate. Click on assign and yes. So in this way, we can add different types of loads on the tank walls as well as on the tank slab. Let us add some manual load combinations. Let us start numbering it from 100. So I say load combination number 100 and let us give it a factor of 1.2 for the dead load, which is the self weight, and the same for fluid load. Okay, so this is one combination. Let us add one more load combination, which is, say it is an empty combination with only a soil load on the exterior part of the mat. So let us say these are the two load combinations. One is the full working combination and one is the empty combination. So now at this point in time, before proceeding ahead for the analysis of this structure, I want to highlight a few errors that could be avoided. So the junction of the wall and slab objects could have been modeled better, and so I leave it as an exercise for the viewers of this video so as to take care while modeling the junctions of two intersecting walls or the wall intersecting with the slab. So basically whenever we are modeling two different surfaces, we need to take into consideration and take care that the elements of each surface has to be connected to each other so that there is a correct transfer of the load and which will further result into the correct analysis of the structure. Once we are done with the loading, we can go to analysis and design. So before analyzing the structure, we need to provide some commands to the program based on which it will perform the analysis. So under the analysis commands option, there are different options before proceeding ahead to perform the analysis. So the no print option will print no analysis results in the output file. If we select the load data option, it will print all the loading data. That is whatever load we have applied. Then the static check provides a summation of the applied loads and support reactions as well as summation of moments of the loads and reactions taken around the origin. Okay, so that is the static check option. Then we have the static load. So the static load option prints everything that static check does. And additionally, it will also print a summation of all the internal as well as external forces at each and every joint. Now this option potentially generates large volume of output. So whenever we opt for this option, the analysis may take in more time. Then the modes shape option prints mode shape values. So this option is much suitable for any high-rise type of a structure wherein we want to track the mode shape for the lateral load. So I was mentioning that it prints the mode shape values at the joints for all the calculated mode shapes. So whatever number of mode shapes are getting generated, the mode shape value will be printed. Now this option of both is equivalent to the load data option plus the statics check. So if we select both, it will print the load data plus the statics check option, and all which in itself says that it will print all the above options in our output report. Okay. So as of now, we are selecting the no print option and click on add to perform the analysis. And in the analysis and design option, we click on the run analysis button. So now once the analysis is done, under the workflow, we can go to the advanced concrete design for designing this structure in STAAD Advanced Concrete Design or RCDC. So once we are in the RCDC environment, we can design the water tank, and a complete video with details of how it can be designed in the STAAD Advanced Concrete Design or the RCDC is covered in here on our YouTube channel. So you can refer to this video of designing water tanks with STAAD Advanced Concrete Design. I have pasted a YouTube video link down in the description, and you can click on that link to directly jump over on this video. So that's all for this series of the videos of modeling the water tank structure in the analytical modular mode of STAAD Pro and taking it to the RCDC for its concrete walls and the slab design.